Hi everybody, today we are going to take a look at angles basically, and what does it look like on the XY coordinate plane. So an angle in standard position means you start right here. This is always the starting spot, positive x-axis. This terminal side, this guy, he's basically a spinner. And he can spin anywhere you want, any direction. He can just spin and spin and spin. So where that side lands is how big the angle is. So for example, if we have an angle that starts here, and then we could spin this other side over here, now you draw in where you want the angle to stop. Also, you're going to draw in this arrow right here. This arrow shows the direction in which you spin, because as you know, you have a different angle measure on this side than you do over here. It's a lot like arcs and circles, where you have a major arc and a minor arc. So which way is it? Is it the short way? Is it the long way? So we need that arrow. If you spin up from zero, from positive x-axis, it's a positive angle measure. If you spin down from that positive x-axis, this is a negative angle measure. And we're going to do a bunch here to take a look at this. We're going to do this in degrees and in radians. So when you start this, you need to start with the entire XY plane. Even if, like in our example, the angles are just in the first quadrant. Please draw all four quadrants. Remember, you're going to start here, always. Then 120 degrees. Well, we don't really care about the precision. We know this is 90 straight up, and this is 180 over here. So it's somewhere in between there. Where you want it to land is up to you. You can make it land maybe accurately or maybe inaccurately. It really doesn't matter. It just needs to land in that quadrant. So again, you draw where you think it should stop, and then you draw the arrow showing the direction in which it spins. Now 270, we know exactly where this is. Everyone should have the exact same location. 270 is clearly right straight down there. So we always start here. So here's our beginning. And we want to go the big way because we want to do 270 degrees. So we spin around this way, and 270 is right there. 135 degrees. Well, again, 135 degrees is somewhere over here, right? It's in this quadrant over here somewhere. So I'm just going to draw it in, and I'm going to stop it. And then if you look, my 120 and my 135, they look very, very similar, if not exactly the same. And that's okay. You're not supposed to be able to tell what the exact measurement is from your picture. It's just supposed to land in the correct quadrant. Close is perfect. Now, negative 200. Let's think through this. We got to start here. Negative means we're going to spin down. So this would be negative 90, this would be negative 180, and this would be negative 270. So we want to land somewhere between the 180 and the 270, and it doesn't matter where. So maybe you make it land right here. And then we draw this showing the direction in which we spin. And again, you can kind of see that these two angles, I have a tendency to draw them right down the middle. You can do the same thing if you want to, or you can make it a little bit more accurate. Now, when you spiral around more than once, this has to be visible on your picture. So 495 minus 360 is 195 degrees. So we're going to go all the way around and then another 195 degrees. So when you do this, spiral it out. There's all the way around. Don't draw this so that it looks like it's right on top of itself and we can't tell how many times you spin. We want to be able to count the number of spins that have been made. So now we're back at 0, or basically 360. Now I need to go 195 degrees from there. So I need to go past the 90, and I need to go past the 180, and it's going to be over here somewhere. That's it. And you can clearly see I went around more than once, and your picture should look just like that, so we can see if you go around more than once. In radians, best way to do this is to look at this line right here. I know we're going to start here. We always start here. Doesn't matter. This is where we start. So over here, you could make this 3 pi over 3, 4 pi over 4, whatever your denominator is, because this is 1 pi, you can turn 1 into the common numerator and denominator. So I'm going to call this 5 pi over 5. So if I'm at 0, I don't need to go all the way to 5 because I'm just trying to get to 4. So it's just going to land right there. Negative pi over 4. Well, anything with a 1 in the numerator is you're just going one quadrant. So if it was positive pi over 4, we would just be up a little bit, like up in here. But of course it's negative, so we're just going to be down one quadrant. So we're just going to go down one quadrant, draw where it stops. 5 pi over 6. Again, 6 is the denominator, so I'm going to think of this as 6 pi over 6. I start here. All right, I started this one here. I'm not trying to go all the way to 6. I just need to go to 5. And so there's maybe where 6 pi over 6 is. Now, as you can see, as a result of spinning, right, I can call it the angle, this angle, whatever this might be. I can call that, let's say, positive 135, just to pick one we used. Or I could call this negative 225. And they land in the same spot. Or I could go all the way around and then land. I could go around 5 times. So there's an infinite number of angles that land here in terms of their angle measure. This is called coterminal, meaning they stop in the same spot. And that's what this is. And so you can see they're using this example of 90 degrees. So you could spin upward to get to 90, or we could spin all the way down and around and call that negative 270. Or we could call this positive 90. They have it in radians there. You can think of it in degrees. So when your question's in degrees, your answer's in degrees. If your question's in radians, your answer is in radians. And this is as simple as adding and subtracting 360 degrees. That's it, because they want us to give a positive and a negative angle. So in your calculator or on your paper, we're going to do 65 plus 360. So 65 plus 360, that's 425. These are angles that are measured in degrees, so please use a degree symbol. And then we're going to do 65 minus 360. Now you want to put the 360 in the calculator second because you want it to come out negative. We're trying to get a negative angle, negative 295. Now with this one, 540, when we subtract 360, it comes out 180 degrees. Well, I subtracted and I didn't get anything negative. It's okay because the positive angle is the answer, but don't add. I got a positive answer. So now I'm going to take where I started from and I'm just going to take 180 and I'm just going to keep subtracting 360 until I get to something negative. This one actually does come out to be negative 180. So we have positive 180 and negative 180 as coterminal angles. Now if we're using 180 all the way around on the unit circle, I don't know why I do that so many times, but that's 2 pi. One full rotation is 2 pi. So 2 pi and 360 are the same. So when you're in radians, you're going to add and subtract 2 pi. Now you can do this in the calculator, but you cannot put the pi symbol in the calculator because the calculator reads it like a decimal, and it won't switch your fraction. So you could do 13 divided by 18 minus 2. Hit enter, then go to math, and hit enter twice. And it should pop back up as a fraction. And then you put the pi symbol back in the numerator. So when we add the 2 pi, I know I used minus as my example, but if we do 13 over 18 plus 2, we would get 49 over 18 out of the calculator, but the pi symbol needs to go back in the numerator. So you have to take care of this pi symbol yourself. Your calculator will do it though. So if we do the subtracting part, 13 over 18 minus 2, we get negative 23 over 18. And again, you have to put the pi in the numerator. So we have 14 pi over 9 plus 2 pi, which will give you 32 pi over 9. And then we do 14 pi over 9 minus 2 pi, which will give you negative 4 pi over 9. Now, of course, you don't need to label and say, hey, here's my positive answer, here's my negative answer, because it's obvious, the positive one and the negative one. According to my, whoa, I don't know what happened. Now, if we take this spinner and say we're only going to spin it with a radius of 1. So my side is a 1. So this is definitely the point 1, 0. And I can spin this thing anyway, and it can land anywhere in here. But if I spin straight up, right, this is the point 0, 1. This over here would be the point negative 1, 0. And straight down is the point 0, negative 1. If your radius is 1, like this one would be, I'm not looking at the circle, I'm just looking at the 4 right angle parts. This is called the unit circle because it is 1 unit. So if you've heard of something called the unit circle, that's what it is. It's a circle that has a radius of 1. 1 what? I don't know. 1 foot, 1 inch, 1 meter. It doesn't matter. It's 1. And what's unique about this circle is that on this unit circle, we have just a few answers that we kind of use. You know, we use right down the middle, we use 45 degrees, we'll use 30, 60. So we use your special right triangles here, and the special right triangles are something you'll have to know, and we'll go over that coming up soon. But today what we're going to do is we're going to take a look at just these 4 that are right on the 1s and the 0s. Now what's nice about the unit circle, and you can see over here, every point on the unit circle goes cosine, sine. It's alphabetical, just like x, y. So the x coordinate is the cosine, and the y coordinate is the sine. And so if you're asked to find, well, what is the sine of 90? Okay, well, 90 is straight up, right? So here I am. I'm looking at my unit circle. I'm looking at this little diagram here. I'm going to go straight up. So if I think about the angle, I would draw it like that. You don't have to draw it. You can use my picture. And so sine is the y value. And all you do is you look at the picture and go, oh, y value? That's a 1. That's all this is. So if you've heard people talk about the unit circle, that's what this is. Not everything, but it is the unit circle. So cosine of 270. So 270 degrees is straight down. Right? So straight down is this point. Cosine is the x value, so that's just a 0. These are side length answers. The question has an angle in it. The answer is side length. So we don't need a degree measure or anything. Pi is right here. This is pi. And so cosine goes with x, so pi is negative 1. Negative pi over 2 is down here, like where 270 is. So the sine of that would be the second number of the y value, which is negative 1. So let's go back over this. I know this is super repetitive, but it is also super, super important. So again, one more time, right in terms of x and y, cosine is x, sine is y. It's in alphabetical order. Now, because this all comes from triangles and circles, we're going to talk about the Pythagorean theorem. So if you think about the Pythagorean theorem, it would be x squared plus y squared equals r squared, right? Side of a triangle, and the radius instead of the hypotenuse. Well, we know our radius is 1, so we can be even more specific. X squared plus y squared equals basically 1 squared, but we don't really need to write 1 squared because we know that 1 squared is 1. But if it helps you to just keep them all squared like you're used to, you can certainly do that. It's not wrong. We just don't need it. Now let's substitute in cosine and sine. Now what's weird about this is we don't square the angle. Like the angle is protected. We just put the square on the word. So x is really cosine, so this would be cosine squared, and then you write your angle. Theta, circle with a line through the middle, that's a Greek letter. Like pi is a Greek letter, theta is a Greek letter, and that's usually used for an angle. Like we like x for numbers, well, we like theta for angles. And then of course y would be sine squared, and then you write your theta. And I'm just going to write it as 1 rather than 1 squared, just to keep it a little bit more simple. And this, because it's related to the Pythagorean theorem, it's called a Pythagorean identity, which means on the unit circle, this is true for every point. Now it has to be on the unit circle. Not on the unit circle, it doesn't work. So that's kind of a big deal. All right, so now we're going to use this Pythagorean identity with some information. So remember, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So they give you some information. It's maybe written in a way that you don't really feel comfortable with, but we'll work through it. So part of it is obviously a trig identity or trig ratio, and the other part is the location. If it's located between pi and pi over 2, so we know exactly where we are. We're right here, right? So we're here in this quadrant. Cosine is adjacent over hypotenuse. So I have 8 over 17. This is adjacent. This is hypotenuse. Now I don't really know. The negative sign they purposely put in the middle, so I don't know which one is negative. So when you draw your triangle, we draw it to the x-axis, and this is the right angle. So I know the hypotenuse is 17, and that this is your angle, always in the corner, and so the adjacent side is 8. Well, if I think about graphing, I went 8 to the left, so that's where the negative sign goes. On this, your hypotenuse is always positive. If it's running on a diagonal like that, we have no idea. We only know if it's negative to the left or down, and this is on a diagonal. So what is that? So we're just going to say the hypotenuse is always, always positive. So now we're ready to go with our information here with sine squared and cosine squared. So I'm going to have according to my formula right here, cosine squared. So I have negative 8 over 17 squared plus, I'm going to just call it y squared, right? Just to make it easier to write. When we square this, we get 64 over 289 plus y squared. Subtract this fraction, put it in your calculator, make your calculator switch it back to a fraction for you, and we end up getting y squared equals 225 over 289. And now we got to take the square root. Now when you take the square root, you don't really know if it's positive or negative. You have to look at the picture to be able to tell that. So if we go back to our picture, this side went up, and up is positive. So we know that the sine, right, because that's what y is. Look back at all these notes up here. So we know that sine of our angle is positive 15 over 17 because it went up. So this is a 15. So the question wants us to find the sine and the tangent. Well, I labeled the triangle so that I could find the tangent. Now things are going crazy. Sorry, I don't know why that's there. We'll just work around it. So for the tangent of theta, if we look at the picture, tangent is opposite over adjacent. It is going to be 15 over negative 8. So we have the sine and we have the tangent. As you can expect, we start putting a lot of ideas together in the second semester. All right. Let's do this one a little differently. If you don't like the picture way, let's just do this straight up with the formula. So we know we have cosine squared plus sine squared equals 1. So they tell us that the sine is 3/5. So we'll just use substitution. And we don't know this. And we know it equals 1. So cosine squared theta plus 9 over 25 equals 1. Well, you got to subtract the 9 over 25, right? Our variable now is this word, which looks funny, but it is our variable. And when you subtract that, you get 16 over 25. Taking the square root, we get that the cosine of the angle is either positive or negative 4/5. Well, again, the issue is you kind of need the picture. The picture tells you everything. So it tells you we're in that same location. So we're over here. Right? So in this quadrant, if you think about graphing, we go left, which is negative, and up, which is positive. And you know that cosine goes with x, and x is negative. So we know that the cosine of the angle is negative 4 over 5. Now tangent is y over x. Or, if you want to think of it in words, it's sine over cosine. But we know it's y over x because it's rise over run, up and down over left and right. So if we think about going back to here, and we know that sine was our y value, right? And cosine is our x value. So we know that the tangent is sine 3/5 divided by cosine. which is -4/5. Sorry, I couldn't find it. So we have 3 over 5 times, flip this over, 5 over -4. And we get that the tangent of theta is equal to -3/4. So you can do this two ways, from the picture if you like that, or just from the formula. Try the homework problems, and any issues you're having, of course, we can take care of or talk about in class, or you can come to office hours if you need extra help.